Hello, hello.
Hello to today's recording.
Hello. Hi, Joscha.
Hello, Andrés.
How is it going?
Very well. I'm so glad that we find the time to finally sit together. We don't have much time today, but maybe there will be a second installment soon.
Yes, absolutely. So, yeah, I mean, I think let's have like a casual conversation about consciousness, intelligence, AI.
Yes, so let's maybe start out with a very simple question. Is consciousness primary, or is it something that supervenes on physics? And if it's the latter, does it exist within communications of neurons, or is it some quantum phenomenon? What do you think?
Yeah, I mean, my working assumption is that the universe is a gigantic field of consciousness, and it follows some behavior that goes according to the laws of physics. In other words, physics is describing the behavior of consciousness, and that this field evolves in such a way that it forms topological pockets, distinct regions of the field that have like a clear inside and an outside, because, for example, the field lines may loop around and create an objective boundary. And I think that, moments of experience are kind of these like looping structures within the field.
Yes.
But in that sense, like consciousness would become primary. It is the ground of being, as it were.
Okay, so we probably need to clarify our terms a little bit. What do you exactly mean by consciousness in this context, and what do you mean by universe? Right? I mean, people use these words, but for instance, physicists often refer to the substrate that we are in, as a cosmos, basically. Whereas when we talk about of our experiential universe, the thing that we can experience as being real, that seems to be a mental content. Right? So this seems to we have to make clear what is the thing that we are pointing at. Do we point at something that we can experience, in the sense of the universe as being the whole of experience in a way, or do you mean by universe something that physicists are studying, or do you think it's the same thing?
Yeah, they're very, very related. So I guess, for context, when I talk about consciousness, I'm really referring to qualia and qualia aggregates. Kind of like in your visual field, you have a lot of like visual sensations. It seems like they're kind of like put together in a field, in a kind of like visual field, as if there was a bunch of pixels and all of them kind of surrounded by a boundary. Now, usually this has representational content. Like almost all instances of consciousness generated by a human mind are about something. And I think for a lot of people, it's very difficult to kind of like hone in on the referent of qualia, because when I talk about, like the way experience feels like, they started with kind of this assumption that, well, what they're experiencing is the world outside, in a sense. But in the QRI world, as it were, your consciousness is kind of this like qualia bundle, these like raw set of sensations that are arranged in such a way that they represent an external environment. Now, that external environment we call the physical universe, but I am essentially think that, like what we perceive of the universe, in a sense, is a tiny slice of what is actually happening around us. As Don Hoffman would say, like we evolved to represent content that is necessary for our survival, rather than represent the physical states around us in like as comprehensive or an unbiased way as possible.
When you dream at night, do you also represent a slice of the world around you, in this sense?
Not in this sense, no. I think you're kind of like instantiating this world simulation that draws from previous experiences, that has like representational content, and in the dream you may very much believe that you're representing a state outside of you. But in my working assumption, it is like a sophisticated hallucination.
Yes. My working assumption for an everyday experience is that it's exactly the same thing, only it's tuned to predict your sensory data.
Yeah.
Which means you get constraints that determine what you can dream. And the dream is the simple structure that your mind has discovered to model the structure behind the sensory patterns.
Yeah, I agree completely. I mean, I think in some sense we're all kind of like sleepwalking,
yes.
But sleepwalking, but constrained by sensory input.
But that would mean that we don't represent a slice of the actual physical universe, but we represent a model over our sensory data. And the sensory data, if we take the results of neuroscience seriously, that they are constrained to what our neurons can detect and hand over to each other. So they're limited by the firing frequency of neurons. They're limited by the sensitivity of our sensory nerves. by the ability of the brain to integrate information and so on.
Yeah, I agree with all of that.
So how does this then relate to the consciousness as being fundamental, right? Because we are now talking about something that is actually message passing between neurons.
Well, algorithmically, to an extent, here's where, looking very closely at the implementation level, detail matters a lot. So one way in which, David Pearce would describe the topic of this conversation is, in his view, consciousness discloses the intrinsic nature of the physical, in that, yes, the content of your experience is representing information about a hypothetical external world, and we're trying to predict sensory data. However, an actual moment of experience, in this view, is an actual physical configuration that has kind of this self-reflective quality, that within the topological pocket that is being generated in the brain, there's, in some sense, kind of reflectors that allow it to look at itself. In a sense, it has a certain self-reflectivity, and in that sense, if you kind of awaken to the fact that this is a dream, in a sense, you can study the properties of the dream and the physics of the dream, kind of dissociating it from the external world. And I would say that actually that is kind of studying the properties of the universe, the intrinsic properties of the universe, which is how is it actually configured inside your brain.
It seems to me that the contents of my experience are not necessarily strongly related to the condition that my brain is in, right? Beyond the fact that my brain seems to be the substrate of my thinking. That is, when I bump my head, then my thinking will change if I bump hard enough, right? And so the contents that I have are about something that does not necessarily have to have a relationship to my brain beyond the fact that my brain is able to represent it. Would you say that a photon has consciousness?
I would say that probably a photon is like a tiny speck of qualia that is kind of being dislodged from one pocket somewhere, and it's being absorbed by another pocket. Kind of this packet of energy would be, at the fundamental level, kind of like a speck of qualia that is migrating from one pocket to another.
I don't really know how that would work. Can you envision this in your mind's eye?
Yeah.
And what is the lowest level of causal structure that makes that happen? What is a photon made of? What do you think is a photon, in the sense that it could have qualia and self-reflexivity? And does a photon have a self-model?
I don't know, and I don't think a photon has a self-model.
Does a photon have enough structure to form this strange representational loop that allows it to experience something?
Well, I don't think kind of this. I don't think kind of this loop of representations is necessary to get qualia. I mean, I think it's more kind of the qualia are the building blocks that are used to kind of manufacture this world simulation that we experience. And so a photon would kind of be one of these tiny building blocks.
Yes.
And most qualia in this sense doesn't have a self model or is trying to model an external world or anything of the sort. It is just kind of this selfless sensation that is happening. It only acquires kind of self-reflectivity and kind of this structure of attention and awareness and the ability to look at itself in very sophisticated organisms like us, where a lot of these building blocks of qualia are put together in such a way that they reflect each other and can actually build this kind of gestalt of what the whole is. But there's many states of consciousness that you can access in meditation where it doesn't feel self-reflective and it doesn't seem like you have a self. It's just kind of pixels of sensation, as it were. And I think that would be, in some sense, give us a bit of an idea of maybe what it's like to be a photon. It's not to be a person or an entity. It's more just a sensation that happens without context.
Yeah, I think we need further translation to understand each other.
Yeah.
Typically avoid the word qualia because it's a concept that has been developed by a number of competing philosophers that did not fully agree on what they mean, right? To the point where then it says the definitions that people have given of qualia are so contradictory that it doesn't make sense to claim that qualia actually exist. But doesn't mean that he's right, but this is basically one of the extreme positions. So what is the work that we want to make the word qualia do, right? So what is it that we refer to? What do we point at? And the way in which I normally talk about it is that I have sensations that appear from the perspective of something that observes.
Mm-hmm.
And these sensations don't necessarily refer to physical objects in the sense of they are not about quantum mechanics or relativity or charge. They are about things that I can conceptualize and experience using my senses and the processing that my brain is performing on the sensory data.
Mm-hmm.
Right? So it's basically features of an embedding space projected into an observer. Mm-hmm. And the observer responds as a model of what it would be like if something would experience that and forms memory of this that allows self-report that then again inform the next wave of sensory features that can be, for instance, about imagination, or they are about content that is generated to explain perception. Mm-hmm. Right? Does it make sense to you so far?
Yeah, it makes sense.
Yeah, so when you are talking about a photon, it appears to me that you're not talking about the same entity that a physicist is talking about, which is a mathematical way to make sense of other mathematical elements of a larger theory that has the property to give rise to whatever causes the measurements of the physicists. Mm-hmm. Right? So it's about a parent universe, it's not an experiential universe. Mm-hmm. Whereas the entity that you're talking about is one that you experience, mm-hmm. right? Not necessarily you as Andrés, mm-hmm. But there is something in your mind that has the ability to experience itself as Andrés, but it's also able to experience itself as a photon. And mm-hmm. maybe or whatever your mind thinks a photon is, mm-hmm. right? Does this make sense?
Yeah.
So are we talking about the same thing, or do you think that your ontology is fundamentally different?
I think there's like background assumptions that need to be unpacked for us to sync up fully. I do think the word qualia is very meaningful to me. Yeah, of course. I mean, there is this entity called Qualia Research Institute that I hear so much about. Yeah. What does QRI do? I suspect your listeners know all about this, but maybe just to state it again. Yes. So we study consciousness and state space of consciousness, mm-hmm. like the range of possible experiences and, mm-hmm. and what gives rise to it, and really like kind of like the similarities and differences mm-hmm. between states of consciousness. And I think like I mean, for some people, when you say like, okay, the blueness of blue, that is not the frequency of light, but is like the actual sensation that you get. Some people get it right away. And it's like, okay, I know what you're talking about. For some people, it's very tricky.
Yeah, it's the property that all blue objects have in common.
There's a lot to unpack there, of course, because a blue object, as it were,
it's not a wavelength, right? You can see this when you build robots that mm-hmm. are meant to detect stuff. For instance, we were building at some point software to run on eyebrow robots that were meant to play soccer. Mm-hmm. And so our first idea was that we can make sense of the playing field by saying this range of pixel values is green, mm-hmm. this range mm-hmm. is orange. And then you notice, the ball is deflecting light on the ground. And so some of the green under the ball is actually tinged orange. Yeah. And vice versa, the ball is reflecting the green back. And so you have this weird thing that the colors are actually, when you actually look at the pixel values, are inverted at the bottom of the ball, where the field is of more orange than the ball is not green. Mm-hmm. And yet your perception automatically corrects for this, because your perception knows this is what orange looks like if it's next to a green surface, and vice versa. And we have this high-level processing that basically makes sense of there's an invariance of this ball and of this field, and this invariance changes when the lighting is changing, but there's an underlying property that your mind is somehow extracting from it. Mm-hmm. And if you try to generalize this over all objects that are associated with green and orange and so on, you get this cluster of features that are one step removed from the percept, right? So when you see red, you might associate love and blood and pain and the color of the working class and whatnot, right? And so this is all one step removed and adds to the content. And there's also the association that blue objects tend to be colder than hot objects, so red appears as a warmer color than green and blue, right? All these things go into the perception of a color for us. Yeah. That's why I also don't think that you can have this inverted spectrum, because but you could have one where one person always gets hot blue objects and cold red objects in their experience, and then when they talk, they have different associations, right? But I don't think that the color is more than this relational property between sensory features. Do you think it's more than this?
I think it is more. I think it is kind of, in a sense, like a fundamental value of reality that is being recruited to then paint over and represent this internal content. And I mean, I do have like an argument for that, and several arguments, but like the main one I would put forth is that you can study the structure of qualia space irrespective of the sensory input that gives rise to it. The classic example is people with synesthesia, right? Like, of course, in principle, you could have like broken eyes, as it were, such that like you don't actually get kind of a color data, maybe just brightness data from your eyes, but nonetheless have like sound to color synesthesia, such that via specific frequencies of sound, you experience a specific phenomenal colors.
Yes. Why do you think that is?
Yeah. I mean, I think that is your brain, like their brains are wired differently in such a way that, for example, neural connections that typically would only feed into the auditory cortex, maybe like cross feed into the visual cortex. And that there's like specific neurons in the brain that have the right kind of internal proteins and intracellular signaling that are responsible for kind of like tuning into and expressing the qualia of color. And in that way, it's kind of like you're using visual neurons to represent auditory input, which I think is like, perfectly valid. And there's like a lot of computations that you can do that way that you can't do if you're not doing it. I mean, synesthesia can be computationally quite advantageous in some contexts. But I do think like that you can, for example, like study the geometry of color space, irrespective of the input with which you instantiate it. I mean, the classic experiments in psychophysics to kind of like study color qualia space is using the concept of just noticeable differences, or like where they show you two colors and they ask you, are they the same or
color
different?
Chips, and then you can get people to arrange all the color chips by similarity, right? And then you can make a map of their color space. Yeah. Of course, limited by the dimensions that you're putting your chips on.
But yeah. I mean, and one overall result of psychophysics of color is that the state space of color is three-dimensional and Euclidean. So essentially, there is a kind of like a black and white axis. There is a red and green axis, and there is a yellow and blue axis.
Yes.
And
what happens to tetrachromats?
I don't know, actually. I mean, like there's two options, and they're quite different. In one option, really what they have is kind of like a higher resolution mapping, where they can tell like more, spectral power distributions of light apart, but they're still using the same qualia space to represent it. That is actually what I suspect is happening, that tetrachromats don't actually have like additional color qualia. They just have kind of like a higher resolution mapping between sensor input and the qualia space. And that if you have synesthesia and you go from like sound to color qualia, you can still do psychophysics experiments where like you could say like a just noticeable difference in color qualia using different frequencies of sound. And my strong suspicion is that if you do that experiment, you will reconstruct the same qualia space. It's going to be like black and white in one axis, red and green in another, and yellow blue in another. And it's going to be a 3D Euclidean space, meaning that I think that, like the state space of qualia and qualia varieties is something that you can study universally, something that an alien could be able to study, as long as they have like a wide enough range of inputs that can trigger every point in that space.
My hypothesis would be that tetrachromats actually do have an additional color dimension, because it seems to me that when you have an additional color receptor in your retina that allows you to reliably distinguish another color feature, then it's not easy to sort the features in such a way that you end up in the same three-dimensional space as you did before. So I suspect that you actually would need to add another dimension to actually make sense of the data. It could be that brains are limited in the way that they don't really like to model four-dimensional color spaces, so this might be an empirical issue. But it appears to me that naively looking at this from a mathematical perspective, they should end up with one more color dimension. But they don't have names for all these colors that they share with the environment, so it might basically be that tetrachromats ending up saying, oh no, these colors are not a very good fit together because they're no longer on a line through the color space, and you need to use a slightly different color in order to get some harmonic result when you, for instance, look for the right clothing or for a website design. but not for website design, because they use three color projectors that are tuned to the sensors of normal Tetrachromats, right? For natural analog features, I think that Tetrachromats will just very often be very unsatisfied with the color choices of other people because they're not a good fit. And otherwise, they basically see things that other people are not seeing, and most people don't really think about the dimensionality of the color space very much. But it seems to me that a color is a mathematical object, and you can describe it by an intensity and an angle. And the reason that it's an angle has probably to do that's represented by a pair of neural oscillators or something. And so you basically have to look at the differential between these oscillators, and you can represent this as an angle that basically is similar to sound as octaves. And because sound is also can be represented as an angle within an octave, and in intensity, there is a mathematical equivalent between the space of sounds and the space of colors. And because it's such a similar mathematical object, if you basically get experiential access to the structure of sound, it will look like a color to you, because it's mathematically pretty much the same thing. There's also this weird thing that there is this subset of the space of melodies that is isomorphic to the space of emotional alignments, right? Which is why we find melodies often emotionally so expressive. And I also suspect that's because they basically use the same encoding. There is some profound similarity in how we represent emotions and how we represent melodies, which means sequences of sounds.
Okay, let me unpack a little bit.
Yes.
I mean, I think, if tetrachromats can actually experience a different axis of color, that it's in how I see it, it would be like a very, testable thing. You wouldn't be able to test it with a normal screen for the reasons that you provide, which is like it only has like RGB. The basis is not large enough to span that space. You could have like a custom made
it would be relatively easy.
Relatively easy.
Yes,
like 4 different pixels.
Use a bunch of LEDs and
have essentially
known wavelengths that are aligned with the wavelengths that the individual is susceptible to.
Yes, and my guess is that if you do a just noticeable difference test in that space with a tetrachromat, that they will be able to tell physical input apart much better than somebody who's just trichromat. But if you do a multidimensional scaling analysis of the just noticeable differences and the space in which those differences happen, I predict that it will probably still actually come out as a 3-dimensional Euclidean space.
Yes. So what we are basically talking about is a form of Hebbian learning, which means you construct your embedding space by looking at similarities. If something is similar to each other, you basically wire it together. You decrease the distance between it, as the more similar things are. And when you take all the objects in a certain domain that you want to relate to each other, you basically measure their similarity by some kind of measure, and the more similar they are, the closer you put them together, and as a result, you get a space with a certain dimensionality. Right, because they're not in their similarity going to be transitively on one axis, but they're going to be on a set of axes. And there's probably a mathematical limit to how many dimensions you can comfortably handle in your brain. Otherwise, it gets too complicated. And so there is an upper limit to the dimensions in which you can things sort within the same space. Right, you can create some kind of fiber bundle, which means the dimensions are unrelated to each other. So you, for instance, space and color, when we perceive, are not really related. You can rotate things in space, but you cannot rotate between space and color. Right? When you look at an object, it just doesn't look the same anymore when its spatial shape changes. So color is a dimension that is qualitatively very different from the spatial dimensions.
I agree. No, and you make a great point. I mean, like empirically, if it turns out with tetrachromats, the embedding space of all of those like just noticeable differences, if it is like 4D, then that would be a lot of new information for me. My hypothesis of why that would be, or how that would be implemented, would be that maybe tetrachromats don't have this kind of like either or inhibitory effect of opponency of colors. So that, like, for example, maybe they have a color that is both blue and yellow at the same time, and maybe another one that is kind of red and green at the same time. But even there, kind of like the basic building blocks, kind of like the 6 primary colors, as it were, which is like black, white, red, green, blue, yellow, might still be the same, would be my guess. except that like some of those dimensions are not completely opposite anymore. Maybe they become orthogonal. So you can have like points in that higher dimensional space.
Yeah. But I think we can easily test for this. Maybe let's do this when we do the next podcast.
Yeah.
You just need to find us a tetrachromat.
Yes. And a custom-built LED screen.
Or just a projector.
Would a projector do it? Because I think RGB,
we need a
right?
projector that uses analog colors.
Yes. I mean, another thing, I mean, I'd like to get your take on is, where does like magenta come from in your perspective? That like, if magenta in some sense is what they call a non-spectral color, where like you cannot generate magenta with just like one frequency of light. It's always like mixtures of frequencies of lights in terms of inputs. And the way I make sense of it is that actually color space in a sense is a wheel that you actually
it's an angle, right?
It's an angle, yes. But you could live in a world where like everything only has like or is created in such a way that you only have like one frequency of light emitted from like every object. In that case, would you predict that in a sense you would like train an embedding that is more kind of like a line as opposed to a circle?
Yes. Yeah, I feel if you live in a world that is only black and white, right, I don't think that you would form color receptors in detectors and classifiers in your neocortex. And so I suspect that when you are confronted with color for the first time, there is a likelihood that you cannot make much sense of it if you already passed the phase of neuroplasticity. I think eventually you'll learn, but I would not be surprised if you see color for the first time that it doesn't make sense.
Yeah. Okay. So digging a little bit deeper, in my conception of the state space of consciousness and so on, there's kind of these like we call them like qualia varieties, where like color is a certain qualia variety, sound is a different qualia variety, and these are not arbitrary distinctions. I think like they do reflect kind of like some deep structure about reality and like what is possible. And one way in which you can show this is that if you take two values from a given qualia variety, there is kind of a shortest path between them, and there's one way of transforming one to the other in a smooth way without kind of like jumps or putting into a space and then making associations or anything like that. And my claim is that you know from any color to any color you can do this kind of smooth transformation, but you cannot do that from like color to sound. Like color, because they're kind of like fundamentally different types of building blocks.
Yes.
And in that sense, like you can study kind of like what these qualia spaces are in a rigorous way with psychophysics and map out these different spaces with different dimensionalities, and they will form kind of these very natural clusters where there's going to be like color space, audio space, the space of sense, and so on. How do you make sense of these kind of partitions or different
I think
qualia
that
varieties?
there is an intrinsic difference between them, which means that each of these data formats has a different statistical structure. This is how we recognize them. So I don't think that basically the brain initially cares very much about which wire enters where, but it is sorting the data that comes through the wires and looks at the statistical structure of these data. And the next thing is when you are integrating over all these data, you find out that colors and sound might correspond to a shared region in the three-dimensional space that surrounds you. And so you're going to associate them with each other in a particular way. And this association is specific and doesn't allow you to merge them because they're basically different types. And the type means you can apply different functions to them when you make transformations.
Is there... Yeah, that's fascinating. Different kind of like statistical constructs. I guess like one thing that falls out of that is that if you create a physical environment with kind of like color statistics that match more kind of like audio statistics, and maybe if you grow up in such an environment, would you maybe predict that you would naturally develop kind of like visual to audio synesthesia in a way? Like if like maybe you start representing the shades of light in front of you as like sounds because the relationships match better kind of the statistical distribution of sound. Yeah,
it's an interesting thing that people who have synesthesia for sound, in the sense that they associate colors with it, that most of them seem to have similar features, right? But not all of them. It would be super nice. It would be the same for all of them. And there are some hypotheses for why so many people who have color sound synesthesia associate the same colors with the same sounds, or with the same pitches in the sound. And some people suggested that's maybe because you learn to a color-coded xylophone or things like this, where that is very ubiquitous in one generation, where you start to associate certain colors preferably with certain notes, and as a result you get the similar mapping. Right, that would explain why some people don't have the same thing. If there was a mathematical grounding, then there is the question: is there an absolute pitch for the color wheel? Is the color wheel always aligned in a particular angle, and is there some stable thing that would align it with the sound wheel, so to speak, with the sound circle?
Yeah. I guess like that means that we could probably figure out how to create a kind of like a toy xylophone that will make a lot of kids synesthetic, just because it carries the right statistical distributions for the different...
I wonder, I don't naturally have synesthesia, but I found that there is a profound difference when I listen to music that is played by a pianist that is synesthetic and not. Because I find that they will say that it's exactly right when they have synesthesia of the sound. And there's basically some kind of long tail of harmonies that needs to be right when they play. And I found that when I listen to the same piece of music rendered by different artists, the effect is a very different one. And it seems to be somewhat correlated to what the synesthetes experience about the sound. So I do suspect that synesthesia is not profoundly different. It just means that if you are a synesthete, you get experiential access to part of your sound processing that other people don't. So I have a pet theory that some of the spectrum disorders are about how many steps a neural signal passes before it's no longer reconstructible. Right? So when you basically process things in your brain, the signal has to hop from neuron to neuron. And each neuron that gets a signal and passes it on needs to basically preserve that signal in a particular way. And depending on how your brain functions, how well the particular neurotransmitter that is important for this kind of message dimension functions and the receptors for it function, this might work better or worse. And there's probably an optimal number of steps that signals should make for optimal classification. If you go too shallowly, you basically end up with some form of autism where you have difficulty to do deep integration, and you're forced to do integration over stimuli directly in the layers before the one where you do the generalization. And vice versa, if you go too deep, you get synesthetic. And that should correlate with you also basically seeing meaning where there is none, because you basically connect lower level features with high level interpretations too much. Right? Whereas in the opposite case, you have difficulty to see a connection between lower level features and high level interpretations. Right? In one case, you are always down in the weeds when you are slightly autistic or severely autistic and have difficulty to generalize. And mostly you solve flat puzzles, scripted things, computer programs, formal logic, instead of perception. And on the other end, you have the artist who is making very deep associations, but has difficulty to analyze them properly and disentangle them. Because it's always integrated over too many layers.
Yeah. I'll have to think about that.
So I suspect that superior mental ability has to do with the ability to tune this parameter. So you basically don't have the fixed parameter, but you can choose how far-reaching your associations are and how analytic you become. So you can basically branch out and then contract again.
Yeah, so like two follow-ups that I'm very curious in your perspective. One is, do you have any thoughts on like what is kind of like the range of Qualia varieties if they correspond to different kind of statistical structures? Like, could we, in a sense, predict the existence of Qualia varieties that humans are not currently instantiating, but that maybe are possible because the math is there somehow?
Yeah, so the question would be, what kind of structure is stable in neural substrate? So that would be the limitation, right? There's maybe a certain degree to which neurons are noisy, and you have so many neurons that you can allocate to a task. There is signal processing speed and the transition speed between neurons, and this limits how much information you can integrate.
Yeah, I mean, when There's sort of like a ontology that comes to mind here is like the state space of possible oscillations in a system of coupled oscillators, where they're like you have like some configurations where, well, if you have like a hierarchical neural network, and you look at kind of like, okay, what are like the stable attractors here? There are like attractors that are stable because, you form some kind of like resonance in a given layer. There's patterns that are stable because they form resonance across layers. And then there's like other things like strange attractors. I mean, something that is like somewhat stable, but is like toggling between one state and the other, maybe in a chaotic, random fashion.
Yes.
And then there's like, states that are completely self-destructive, that maybe like they just exist for a brief moment, but then like they cannot stabilize.
Yes.
So are you saying that maybe the space of possible qualia varieties might correspond to the space of possible kind of like stable attractors in systems?
That's one of the aspects. Another that's related is addressability. But if you have a state that you cannot evoke in your memory, it's very difficult to refer to it later on. And so you have to be able to distill a bunch of features from it that you can then use to induce a similar configuration at a later time. And if you are unable to do this, then this thing might as well not exist, right? Because you cannot reliably refer to it.
Yeah. Okay. So then, we're talking about it essentially like the state space of stable attractors in systems of coupled oscillators that are addressable and can be replicated, and you can have like memory about them and maybe even compare them side to side. Yeah, that probably constricts the state space quite a bit, for sure.
Yes.
But it's not an infinite space by any means, right?
Yes.
It's in principle like studyable. In principle, in computer simulations, we could make the kind of like a periodic table of like self-organizing principles that are stable. One very novel, fascinating perspective in neuroscience that tries to explain psychedelic effects and drugs effects in general is this paradigm that is called divisive normalization. I don't know if you have encountered it. They're talking about it as kind of like a principle for canonical computation, something that they think it's happening like essentially like everywhere in the brain and the nervous system to different extents, and that a lot of the computation that happens is kind of like when you stack together a bunch of these canonical computations. So the idea is very, very simple actually, which is that for a population of neurons, the probability that it will kind of like fire or have activity is a function both of inputs into it and also the surrounding context within the layer where it inhabits.
How is that not input?
It is a different kind of input, but you could imagine as kind of like input from like memory or the context, as opposed to like input from like new sensory signals.
Is this distinguishable from the perspective of the individual neuron, or is this some kind of emergent distinction?
I'm not sure. I don't think it's distinguishable from a given neuron. I mean, maybe it is because from where it's getting the signal. But
so you would expect that the cortical layers, for instance, respond differently to stuff that is happening in the same cortical column versus far apart. Yes.
Yeah. And effectively, what some of the neuroscientists like Marco Achille and people in that group are finding is that one of the things like psilocybin does, for example, is it changes the balance of kind of like how much the surrounding neurons in the same layer inhibit a particular population of neurons. So that like usually there's kind of a lot of like lateral inhibition, and they're claiming that based on like neuroimaging studies on people on psilocybin and doing like kind of like scans of edges throughout their visual field, that essentially on psilocybin you have less of kind of this inhibitory control from the surrounding neurons, and in that sense you get kind of like a more faithful kind of like response coming from the input, in some sense giving a little bit of validity to this idea of kind of reducing the priors in a sense. And that if you stack, a lot of these layers together, and each of those layers now is taking into account a little bit less the context, the possible attractors that arise are very different. How does this sound?
Plausible. I mean, we seem to have some bottom-up, top-down mechanism when we have perception. In our architecture microcell, we model this with a process that Dietrich Dörner called hypothesis-based perception, or hypercept. And hypothesis-based perception, the idea is that your sensory input is cueing you to come up with a bunch of hypotheses of what you're looking at. And this is the bottom-up mechanism. And it's a space that is simultaneously activated. So it's basically you have a superposition of possibilities of what you're looking at. And then you will have a top-down process by which you have mutual inhibition between conflicting hypotheses. And you also actively start looking for features that reinforce or contradict one of those hypotheses, right? So you actively start to have perception that checks whether something can pass for a particular kind of feature. And this active perception allows you to interpret feature as reinforcing your object that normally would not even be salient, because you filter your perception to see if something is compatible with you looking at this feature rather than this being a perfect match. Mm-hmm. So that's why it's also possible for you to work with occluded objects and to recognize things in fog and when they are not sharply rendered and so on, because you just fill in these gaps based on these hypotheses. And this process is not, there is one layer of hypotheses and one level of perception, but it's a multi-stage thing where you have a hierarchy of more and more concrete features towards the perception and more abstract towards the classification. Mm-hmm. Right? And by propagating activation back and forth, this thing eventually settles into a state where you are able to track your sensory data. Mm-hmm. That's the rough intuition, right? Mm-hmm. And this is very compatible with what you just described. Yeah. So you have a bottom-up mechanism like in a vision model that is looking for more and more complex features, and eventually these features correspond to objects. And you have a downward propagation where you are basically organizing the features into the shapes of the objects, and the objects are claiming the features that belong to them. Yeah. Right. And what you describe is when you remove inhibition, then there will be a greater chance for a feature to fit into a larger variety of objects, and conflicting features may no longer inhibit each other. So the superpositions remain present and get integrated into the next level object, right? And to some degree, it's what we might have seen in the Inception work that Blaise Aguirre's team did at Google at some point, where they were taking neural networks that were implementing vision models, were trained on varieties of image databases, and then formed hierarchical models of those features. And then they basically reduced the inhibition and allowed top-down this thing to activate more interpretations. And by feeding this back to the equivalent of the sensory neurons, figuring out which of these neurons get activated and so on, they got massively overfitting things that look very much like psychedelic imagery.
Yeah. Yeah. No, that makes sense. So yeah, if you have the activation propagate across the hierarchy, and on each step you have less inhibition, then it's kind of like more features are tagging along.
Yes.
Kind of
so this is not exactly proof that this is how it works, but it's a strong hint and gives some evidence to that we are on track of with the neural network to discover important mathematical features of the organization of perception in the brain. What would, of course, be more interesting is if we can reconstruct particular artifacts, right? So famously, for instance, ayahuasca creates these Shipibo patterns in many subjects that the Shipibo Indians are painting on their vases and weaving into their carpets because they are familiar with this on their ayahuasca experiences. And this is a very specific artifact that happens in visual perception when you add this particular kind of chemical, which means there should probably also be a way to induce the same features in a computer vision model, if the computer vision model is a good model of human perception.
Yes. That's, essentially one of the things we're trying to do with what we're calling the replication tool, which is, like a system of coupled oscillators that generates this very psychedelic looking patterns. Mm-hmm. What we're trying to essentially find is in what way kind of like the coupling dynamics, what we call like the coupling kernel, is like how different oscillators want to be the same or different with other oscillators at different distances. How the particular kernel generates visual effects that then people rank as being more LSD-like or psilocybin-like or, 5-MeO-DMT-like and so on. Would you say like if an approach like this, if a particular kernel is reliably kind of like classified as, let's say, like, oh yeah, these are like ayahuasca-like visions, do you think that would be like a useful or valid empirical
I think it would definitely be interesting evidence that you are on the right track in modeling this kind of artifact. But to go back to our initial question, is that not all evidence that your brain is some kind of computer made from neurons, and that consciousness is a pattern that is woven by these neurons rather than the other way around?
Well, it is a lot of, it is very much I would say like it's compatible with both views. So, I mean, where I would go next essentially is, okay, like how concretely, like the low level features and the high level features get actually put together into a unified experience or a unified representation. I gather that you think of it in terms of resonance, perhaps, across the layers?
Yes, but ultimately resonance is one perspective of looking at what neurons are doing. You could very, very informally say that there are 3 paradigms in neuroscience about how brains represent. Right, one is the soup theory, which basically says it's all chemicals, and if something is missing, you need to change the configuration of the chemicals, and then you're no longer depressed, and you can see better. Of course, that's very cartoonish right now, and that's also the point to make this as strongly as possible. But I think that's mostly something that you find in pop sci, where people say, "Oh, love is just chemical," right? And then there is the circuit theory, which basically sees neurons as electrical circuits similar to transistors and gates that they're forming. Maybe there's some crosstalk between the wires, but ultimately it's very similar to something that happens in electrical circuits or computer chips. And then there is the wave theory, which basically says that all these neurons are vibing with each other by forming some kind of an ether in which they pass activation waves to each other, and each neuron is taking this activation wave, modulates a little bit, and hands it on to the next one. And so the right paradigm is really resonance and oscillation. And I think that, of course, all these 3 paradigms are part of the story. Each of them alone is insufficient to explain what's going on. And each of them are true to some degree. But the question is, how do you put them together in the right way to understand what's going on?
Yeah. I mean, the perspective of like how, I think like resonance must be like part of the story, but I don't think it's enough to account for binding and the unity of experience, because it's not instantaneous and it doesn't have kind of this crisp kind of transitivity property that in our model, like if you have 2 sensations, part of your visual field, and a third sensation part of the visual field, if A and B are part of the same visual field and B and C are part of the same visual field, A and C must also be part of the same visual field. And I'm not sure like how you get kind of like that transitivity by default just with resonance, because resonance can happen across many different axes. And so like A and B being in resonance and B and C being in resonance doesn't imply that A and C are in resonance as well.
So I wonder if you basically had some kind of carrier frequency where the individual neurons decide which part of the wave they want to be part of. Right? They just need to fire at the moment when the wave is passing through them.
Yeah.
And they basically, it would depend on what they tune themselves to. It's somewhat similar as the binding problem is between 2 people who use a radio to talk to each other over long distances, right? There is this big radio amateur community in the world that if they want to talk to each other, they first of all need to have reception, which means there needs to be enough substrate connection between them to get a signal across. And then they need to tune into the same frequency and also make sure that nobody else who has a stronger signal and conflicting messages is sending something else that is incompatible with what they are sending.
Yeah.
Right. So basically, you need to agree on some kind of protocol. In the case of radio, that's very simple and straightforward because it's very close to the physics of the sound that you are recording, modulated onto the frequency emitter that you use for electromagnetic signal transmission. But in the case of, say, there's frequency coding. In the case of, for instance, mobile phone connections, it's much more complicated. And you have an extremely complicated protocol that allows you to put much more information into the available bandwidth and share this channel. And so if you think about how neurons are doing it, we may be thinking sometimes, do they AM encoding or so amplitude modulation or frequency modulation when they talk to each other?
Yeah. No, I mean, I think that is very promising. Something, kind of like a carrier frequency that is providing the underlying glue, and then the neurons are kind of like painting the values.
Yes, so that is one thing that I don't really understand in your thinking yet. You seem to believe that the binding problem is extremely difficult, and it seems to be an extremely important problem.
Yes.
And I somehow miss that. I don't get it, because to me, I think, well, there is a binding problem, for instance, when you are talking to a bunch of web servers to fetch a website. over many, many different servers, right? Some of the stuff comes from Google, some of it comes from a database of fonts on the other end of the planet. It's not a problem, right? You basically have this binding that happens in your browser at any given time. And at some point, you basically release it and to connect to a different website and to a different set of servers. And the way in which this works is you have a protocol that allows you to form some kind of handshake. And once this handshake is established, you assume that the signals that you're getting are still yours. And when the signals are not coming with the same protocol for a while, you assume that the connection has been lost. And so the simplest way would be, imagine you are saying in a submarine, and the submarine can only receive knocking noises. You are very deep in the Mariana Trench, everything is pitch dark. And the only thing that you hear is knocking noises. And there are a bunch of other submarines around you, and you try to listen to them, and you get these knocks, and you want to know, is he talking to me or not? Right? And so what you could be doing is that you, in regular intervals, start knocking, and you see if and you vary a little bit, and see if the other side is following your variations, and you always get an answer. And when this is happening bidirectionally, you know that you are actually in some kind of communication. And so you could evolve a very simple protocol that allows you to perform these handshakes. And it would, at scale, look like a group of cells tuning into the same frequency. And then you get a brainwave, which means such a large number of neurons is sending signals at the same time that you can't catch it with a crude instrument like an EEG sensor through your skull.
Yeah. I mean, I would say I am quite insistent on thinking, the binding problem is really complex. And the reason is because, I mean, when I talk about the binding problem, I'm referring to the phenomenal binding problem as opposed to kind of like a functional binding question. And I think like functional binding, I completely understand it's kind of like a solved problem. And in a classical neural network, I can totally agree. Yes, okay, like from a functional perspective, the features are in some sense being correlated, being put together, and the answer that you get is kind of like this integration of a lot of pieces of information at once. However, that is different than kind of like putting information together to generate a unified experience, because the unity of experience has kind of this objective quality to it, where there's like a precise amount of information that is contained within the moment of experience. And if you were to kind of like establish a communication protocol between two experiences, as it were, I think like even if you sync them up in a way and they can predict each other, that doesn't mean that they will generate a unified experience where, let's say, you have two visual fields at once and two tactile fields at once. Somebody might say like, well, that's just kind of like a matter of what is the bandwidth of communication. But I think there's like something more difficult going on, which is that whatever the channel of communication that you're using, in some sense, is only kind of like sending packets, which are like a tiny subset of the actual richness of your experience.
Yes, but for instance, we have two retinas, and these two retinas are being pieced together in the visual cortex after going through the LGN, basically in the middle, and they're pieced together based on neighborhood. So basically, you reconstruct the shape of your retina in V1. And that's because the neighborhood of the neurons is established by the statistical likelihood that they're firing at the same time. And so this is sufficient to figure out the topology of your retina. Right? But the topology of your retina is not the same thing as the topology of the space that you're looking at, because it's two-dimensional. The space that you're looking at is three-dimensional. And that's because the simplest mathematical model that you get for the correlations between the two retinas is that there are two surfaces that are receiving images projected from the same origin in a three-dimensional space. Right? And this is a mathematical regularity that our brain is figuring out by doing enough statistics. And there are not that many ways in which this puzzle can be solved. Right? It's a puzzle that your brain needs to solve by putting the two retinas together in the right way. So you recognize that you are looking at three-dimensional objects. And there are some circumstances where it doesn't work super well. For instance, when you put on glasses with different colors, it might be that you don't recognize the same objects when the world is tricky, right? But by and large, there is only one solution for this puzzle, and that's why you converge. And it seems to me that consciousness is related to establishing this coherence. And the result of making things compatible when you integrate everything is a single mathematical structure. It's one where there are no constraint violations anymore, where everything is a single object. And so the unity of experience is the result of you piecing everything together in a scene in the same game engine. And everything that doesn't fit into the scene, that you don't know how to fit in, that is not compatible, that produces contradictions, is not integrated. This is just noise and craft that is outside of what you can make sense of. And so my hypothesis would be that consciousness is precisely subjectively this bubble of nowness where you can make everything compatible, where you can make everything unified. And unified not in the sense that it's one point, but in the sense that it's one cohesive structure that has no contradictions within itself.
Yeah.
And you build the largest structure that you can make that has no such contradiction at any moment, that fits into your working memory.
Yeah.
By the way, I think we are slightly out of time for now.
Okay, no worries. This is fantastic.
Yes,
thank you for
I
getting started.
enjoyed this very much. I wish we had more time, but I think we can continue soon.
Beautiful. Well, thank you so much. All right. Thank you, everybody.